Hi everyone, welcome to today's video. Today we will explore how Bayes theorem used in machine learning for classification problems. Bayes theorem is a fundamental concept in statistics and machine learning that provides a framework for reasoning under uncertainty. It is named after Reverend Thomas Bayes, an 18th century English statistician who developed the theorem to address problems related to conditional probabilities. In this video, we will explore Bayes theorem and its applications in machine learning. Before going to understand Bayes theorem in detail, we need to know few of the concepts like random variables, joint probability, and conditional probability. A random variable is a variable whose value is not known with certainty, but instead takes on different values with some probability distribution. For example, if we toss a pair coin, the outcome like heads or tails is a random variable because it's uncertain which outcome will occur. And joint probability is used to compute the likelihood function, which represents the probability of observing the data given the value of the parameter of interest. The likelihood function is a key component of Bayes theorem and is used to update our prior beliefs about the parameter. Joint probability is a fundamental concept in Bayes theorem that allows us to compute the probability of multiple events occurring simultaneously. It plays a crucial role in the Bayesian interference and is used to compute the likelihood function, which is necessary for updating our beliefs about uncertain quantities. And the next comes conditional probability. Conditional probability is a fundamental concept in probability theory that measures the probability of an event occurring, given that another event has occurred. In other words, conditional probability allows us to update our prior beliefs about the probability of an event based on new information. For example, suppose we toss a pair coin twice and we want to calculate the probability of getting heads on the second toss given that we got tails on the first toss. So we can use conditional probability. The probability of an event A based on the occurrence of another event B is termed conditional probability. Now we will see what is the definition of Bayes theorem. Bayes theorem is a mathematical formula that calculates the probability of an event based on prior knowledge or information. It states that the probability of a hypothesis or event H given some observed evidence E is proportional to the probability of the evidence E given the hypothesis H multiplied by the prior probability of the hypothesis H. To understand Bayes theorem better, let's consider a classic example in machine learning, the spam filtering problem. Suppose we have an email that needs to be classified as spam or not spam. We can apply Bayes theorem to estimate the probability of the email being spam or not spam based on some features of the email, like the presence of certain keywords or phrases. In this case, the hypothesis H or A is that email is spam and the evidence E is set of features that we observe in the email. The prior probability of the hypothesis P of A or P of H is the probability that any given email is spam, which we can estimate based on the historical data. The likelihood P of E bar A is the probability of observing the features E given that email is spam, which we can estimate from the same historical data. Finally, the marginal likelihood P of E is the probability of observing the features E, which we can compute by summing overall possible hypotheses spam or not spam. For better understanding, let's take a problem. As you know, COVID-19 tests are common nowadays, but some results of tests are not true. Let's assume a diagnostic test has 99% accuracy and 60% of all people have COVID-19. If a patient tests positive, what is the probability that they actually have the disease? So let's take 100 people for our experiment. So 60% of all people have COVID-19, means out of 100, 60 having COVID and 40 people are not having COVID. And diagnostic test has 99% accuracy. So we can calculate for the people who are having COVID and which are not having COVID, the true positive and false positive and true negative and false negative. And finally, the total units which we have positive results is around 59.8. So by using Bayes theorem, we can calculate what is the probability of the people who tested positive having COVID, which comes around 0.993 probability value. Bayes theorem has many applications in machine learning, including classification, regression, clustering, and anomaly detection, etc. In classification problems, Bayes theorem can be used to estimate the probability of an input belonging to a particular class based on the observed features. In regression problems, Bayes theorem can be used to estimate the posterior distribution of the output variable given the input features. In clustering problems, Bayes theorem can be used to estimate the posterior probability of the input belonging to a particular cluster given the observed features. In conclusion, Bayes theorem is a powerful tool in machine learning that allows us to reason under uncertainty and make decisions based on the probabilities reasoning. By understanding and applying Bayes theorem, we can improve the accuracy and reliability of our machine learning models and make better decisions based on the data. That's all for today, guys. Thank you for watching the video.